Okay, so now I want to start working on the encoding for flipping around the operands. So for example, allowing memory access in the source position. But I also want to start sort of making the emit function a bit more generic so that I can just select, for example, the form of an instruction and have everything related to that instruction on the form. So maybe actually I'll start with that instead. So we'll go with encoder. So instead of having this big switch here, which just knows what the op is, I instead want like a table of forms that I can match on. So I'm just going to have a new file called forms. So this is type form will be a struct. And a form will basically just be representing something in the instruction tables. So for example, in MOV, we have a form where it's RM is the first operand, register is the second operand, and it's like, you know, a size of bytes. And then there's the same thing with word, dword, qword, and then there's the same thing here, but the operands have been flipped around. And I want to be able to, when you call emit, it should take the arguments that are passed into it, try and match a form from a table, and then use the information on that form to help generate the bytes that are needed for the encoding. So when I'm trying to find a form, I'll need the width. We'll also need op1, 2, 3, and 4, which can all just be uint64s. And the reason for these being uint64s is basically just because we don't care about what the value of an operand is in the case of a form. We only care about what, like the information about it, like is it register or memory or something like that. And then when we match a form, we want to make sure that we've got stuff on it like the opcode byte. But for example, with syscall, we also need to know what the opcode map is. So we'll have like a map. So this can be an opcode map. So we have type opcode map, and this would be, for example, map primary. This would be ITA opcode map. Then we'll have map 0f, 3.8, and 3a. So those can go in here. And then we'll have just any like information that's needed. For example, syscall and ret don't need a modrm to be generated at all. So in the info, we'll want to say that, for example, we'll have const no mod rm, and these can just be bit flags. Then we'd want a table of forms that we can loop over based on indexed by the operation, and then we'll try and match like the closest one. So we'll have our forms equals an array of slice of forms, or form. And then this is, for example, we'd have op syscall. And then this form would be, for example, there's no width or anything on a syscall, there's only the opcode map and the opcode byte itself. So in this case, we'd set map to map 0f, and then opcode would be, I think it was 5. And then similarly for opret, we'd have the same sort of thing, but this was C3. And this is just the primary opcode map, so we can just leave this blank. And then for something like MOV, this is where we'd actually need widths and things. So these don't have a map, but the current opcodes that I'm matching on, or that I'm selecting in the hard-coded function that I've got right now, are 8.8 for the byte width one and 8.9 for the other widths. So in this case, I'd say that the width is byte, and op1 would have to be reg or memory, and op2 would have to be a reg. And then for this one with 8.9, this would basically be word or dword or qword. Same again, it would be op1 is reg or memory and op2 is just reg for this particular opcode. And for these two down here, I would want to also set the info to say no mod rm. so that the emit function, when it's got this form, it knows not to emit a mod rm for these particular instructions. So I'd match by basically saying, does the width match the width that was passed into emit, and then do the operands match the flags that have been passed here. So it'd be useful to have a couple of helper functions here on the form. So we'll have func f form is width, and the width could technically match any of these widths. So the widths are defined as bit flags. So we can just pass in width, which can be a width, and this can return bool. So we'll return f.width masked by width, and we'll just say that if any of these widths are set as bit flags here, we'll say that it's true. We'll then also have the ability to check if all of the operands match in some way. So we'll say operands match, and this will basically be op1, op2, op3, and op4. These are all uint64s. And what I want to do is that I don't want to have a special sentinel value for operands that are being ignored. So I'll just say that if an operand is ignored, we'll just say that it's 0. So we'll basically just say that, for example, return op1 is 0, or op1 masked with, oh, this should be f.op1 is 0. So if the forms operand 1 is 0, or the forms operand 1 masked with op1 has any bits matching, then that should be a pass, I think. So basically, if it's 0, then we skip it. Or if it has anything that's matching, then that's a pass as well. And then we basically just need to do this for each of the operands. So that's 2, that's 4. Okay, so that's all of them. So all of them can be optional. Or have at least one bit set. So I think then I just need the ability to match a form in emit. So if I just say var form is form, and then we'll just loop over all of the forms in forms indexed by the operation. So what I'll do is say that if the width is just nothing, if the width has not been set, so for example, syscall and let me see, syscall and ret will have 0 as their width. So if the but if we're not setting the form width, I think that if a form doesn't have anything set, then maybe we'll just say that that's an automatic match. So we'll say that, for example, if the form width is 0 and form.op1 order with 2, 3, 4, if this is 0, then we'll just immediately say that form equals f and break out of it. Otherwise, we'll want to say that if f dot is width, and we'll pass in the width that we've been given to emit, and f.operands match. So this will be op1.info, because we only want to pass the flags in. Op3.info and op4.info. If the operands match and the width matches, then we'll also say that form equals f and break out. And then if by the time we get down here, the form opcode, let's say, is 0, then we'll just panic to say could not match an instruction form. So let's just check to see if that actually matches things. So if I do go test, okay, well, it doesn't panic, so it's obviously matching things. So that means that I should be able to get rid of this switch now, and the hard-coded opcodes here. And now this should break. So it's actually working for all of the MOV ones, but that is because I'm hard-coding the opcode here. So instead of using opcode as a hard-coded thing now, we'd want to pass in the form opcode. And then, let's see, so we're now getting 05 then C0, so this is because it's outputting a mod RM. So the opcode I will do separately, and the mod RM is just this entire block here. So if if RM is mem, I think I only want to do this if the form, I'm going to add another helper called has no mod RM. So if the form does not have no mod RM, then I want to output it. And before this is where I need to append the opcode. So append e.code form opcode. So I'll just need to add that extra has helper. So has mask, this will just be a byte, and this is going to go on the info. So we'll say that if any of the bits are set in here, then that's a return true. So now declared not used mod RM. Yeah, okay, so I need to add, oh, this one needs to move up here, okay. Okay, so that's made these ones pass, but now I'm missing the opcode map. So that is where, before the opcode, we'll just do a switch on the form map. And in the case that it's 0f, we'll just say that e.code equals append e.code 0x0f. In this case, we do 3.8, so this is 0x0 or 0x38. And then this one is 3a. Okay, so that makes all of them pass. So now if I go to the operand encoding assembly tests and create some tests where memory is on the source side, so if I just take the top test from all of these ones here and just put them down at the bottom, this top one I'll change to ECX to make it a bit simpler. And then we just take all of these memory operands and put them on the other side. We'll just regenerate NASM. And then in the encoded test, I just need to create those tests as well. So that is basically all of these top ones. This is going to be D word now, and then all of these memory ones here needs to just shift across to there. So now if I do a go test, this should actually panic because it's not going to match, I think. Yep. So now in the forms, I should be able to just add a couple more forms here where I just move the memory flag over to op2 instead. And then in the MOV table here, the ones where RM is on the source side is 8A and 8B. And then if I rerun these, okay, so now it's mostly working, but the mod RM is incorrect. So the mod RM, okay, that's because up here I'm still assuming that RM is op1 when now it's actually op2. So I want to say if, for example, the form that I found, if the operands match reg and memory, and we'll ignore the last two, then in that case we'll just swap the RM and the reg around. Okay, all right, so that's a basic matching system. It can be improved as I add more instructions.